All right. Hi, everyone. Thank you for coming and watching my presentation. I see a few people. Nice to see you again, Maximilian, and also Brian. I hope hopefully, you can answer my question I asked a little bit earlier about who you think the Patriots should draft here in a couple of weeks. But with that said, yes, as Mala introduced me, my name is Billy Korando. I'm a Java developer advocate with Oracle, and we're going to be looking at Java 22 and also a little bit into the future. So, important information, please ask questions. Well, I've updated this presentation a little bit for this one, but I've overall given this presentation plenty of time. So, don't hesitate to ask questions at any point. I'll be monitoring the chat log. So, if you have a question at any point, I'll be happy to answer it then. Also, feel free to reach out. You can shoot me an email at billycarando at oracle.com. And I just updated this presentation. So if you go here, you'll actually be able to see this presentation that I'm giving right now. So that includes like all the links as well that I will have in this presentation. If you would like to know more, definitely check out our dev.java. So we both have also a playground that you can use to test out like a lot of the new language features I'll be covering in this presentation, as well as tutorials on all the various Java technologies out there. There's Insight.java where we post articles that like our JDK engineers write about the about new features coming out, and then our YouTube channel. So I'll be actually posting a video here next Thursday that I kind of go through like the full release notes of JDK 22. So that gives you even a fuller picture of what's coming in JDK 22 than you'll see here. And also, we'll be hosting a live stream on the 19th on the release day of JDK 22, where we'll be interviewing JDK engineers and demonstrating the new features coming in JDK 22 and more. So definitely check that out. We'll kind of put that post out here pretty soon. And finally, check out our Inside Java podcast at anywhere you listen to podcasts. All right. So for the agenda, I want to do a quick review from JDK 11 to JDK 17. I'm think we're finally getting most of the Java ecosystem past JDK 8, but I'm sure there's still many Java developers that are on JDK 8, or maybe you only just recently got to JDK 11, 17, or even 21, and it can still be kind of good to kind of go through some of these features that we were added during this time span because maybe you kind of forgot about them, or maybe there'll be a couple of things that could show that you maybe didn't realize. Then, of course, we'll actually get into the new features post 17 into JDK 21 and 22 for both language features, API updates, runtime features, and some deprecation removals and other changes to know about. And then finally, we'll get into some of the features that are coming in versions beyond JDK 22. All right, so key changes between 11 and 17. Uh, we'll see if Jaden Daniels or Drake May makes it that far. Answering Brian. So text blocks. I was pretty excited when I saw this feature was added. So this was added in Java 15, and it is JEP 378. So what I mean when I say JEP 378, that refers to JDK Enhancement Proposal. So whenever a more significant change is proposed to the JDK, it goes through the JDK enhancement process. And so you can go and see all the different JDK enhancement processes if you go here to open. Why is it not? Come on. There we go. So if you go here, HTTPS, OpenJDK, or JEPs/0, that will give you a list of all of the different JEPs that have been proposed. And then, for example, text box is 378. And so if you just simply add 378 at the end there, that will take you to this specific JEP. And so that can give you a lot more information on these JEPs than I can actually cover in this presentation, because if I did it for all these different JEPs, well, we wouldn't get that far into the presentation. But yeah, they were added in Java 15. And one of the simplest ways to demonstrate their usefulness is like if you had to work with, say, JSON. If you were having to do this with just old standard strings that were one-dimensional, this would quickly become almost illegible. This really simple JSON message, because you would have to be escaping all the quotes. You would be probably adding like little tab characters as well in here, or space characters as well. And so it'd become illegible. It'd be very easy to say you forgot like a little comma, But now with two-dimensional strings text box, this JSON message can just be written as you would actually view it and as it would actually be rendered, which is very nice. Switch updates. So these were added in Java 14, and this is JEP 361. And so switch updates, they're in the JEP, they're kind of called switch expressions, but I kind of switch it to switch updates because it covers multiple changes. And so the big change is the adding of the arrow syntax. And this works for both statements, like in this example, and also expressions, which I'll show in just a moment. But what's really nice about it is when you match on a case, only the code to the right of the arrow will actually be executed. It's not you wouldn't have to include a break to prevent falling through to a following case, which was added because it was very efficient for CPU rise, but kind of really we learned over time that it's rarely something that developers would actually like, and then it just made code very difficult to read and understand, because even this simple switch statement, if I was to write it in the old break syntax and colon syntax, it would take up almost this entire screen, and it just becomes very difficult to read. And it's very easy to forget to add a break statement. Maybe you're debugging or making some sort of refactoring, and then all of a sudden you have a bug. And so that is also the case now as well with expressions, where you can actually yield a value out of a switch, which is also a bit nicer than maybe having to put a bunch of return statements within your case statements as well. And this will continue a trend of what I was talking about with Mala, and what you kind of referencing is all these changes. We're not just kind of like throwing these changes at the wall and just kind of seeing like, oh, this is nice, oh, this is nice, this is nice. This is all kind of coming together, and and it's coming together in a way of making both Java more concise, because that's often been a criticism of Java, is that it's very verbose. But in conciseness, it's not just about, oh, less typing, but it's also less error prone. Again, not having to worry about including a break statement makes this code less error prone, because you're not going to accidentally fall through to the next case when you're expecting it. So, you're just less likely to have errors, and it's also easier to read. And easier to read code is also less likely to introduce bugs later, because following developers will be easier to maintain it because they're not trying to get through the syntax and structure of the code. Uh, So yeah, someone asked the question is, can you mix arrow syntax and colon syntax? Uh, and no, you can't mix those within the same switch. You'd have to choose either one of those. But you can, and I don't show it here. But you can have a multi-line statement in even when using the arrow syntax. So you could just have the curly braces. And so here, if I was doing it with an expression, that would just need to end with a yield, where you're going to be, I guess, yielding or returning that value. Or here in just the switch, you could just have curly braces and whatever lines you want to execute, and then you simply wouldn't need to include a break or anything in it. Great question. Sealed classes, these were added in Java 17. And so, what sealed classes do is they allow a class to define what classes that can extend it. So, here I'm showing this user class, and it permits the classes admin, customer, and guest to extend it. No other classes beyond these can extend off of user. When you create a sealed hierarchy, then those classes, customer, admin, and guest, must declare what can also extend off of it. And there's three options. There's non-sealed in the case for customer, which effectively makes it a normal class, so anything can extend off a customer. There's final, which is nothing new. Final just means obviously nothing else can extend off a guest, or a class can also be declared sealed as well. And you can also see here in just two examples. This one I'm using permits. When you're referencing classes external to this source file for a user, you would use the permits clause to say, okay, these are classes that can extend user. Or you can optionally define classes within the same the class you define a sealed class, like I am with admin, in which case these are the only classes that can extend admin. So permits is actually an optional clause. These are the two different ways you can actually define a sealed hierarchy. And we'll see how this also kind of has a nice um, uh, combination with another feature that was added in JDK 21, pattern matching for Switch. We also then have records, and this was added in Java 16, JEP 395. And records make up the central element for kind of our new data oriented programming paradigm. And records is a transparent modeling of data as data. And it's really nice because when you define a record here in the case of a person, you kind of immediately know everything you need to know about this record. Whereas with a class, you would actually have to read into the body and structure of a class to really understand about it. So that's a really nice thing. It's, again, not just about being concise, reducing verbosity, but also about improving the readability and intent of the code as well. There's a few things with records. They can't be extended, are abstract, and they're implicitly final. All the fields are final, but it's only shallowly immutable. So, for example, if like one of these fields was a list on an array, you could still change elements in that array, but you couldn't change the array itself. So that's something you definitely want to be careful of when using records, is that you either when you get a mutable object like an array or a list or something like that, you would want to make a copy of it when you're bringing that value in, and then you would want to return a copy when you're retrieving it from an accessor to make sure that the no one's accidentally modifying a field without you expecting it. Also, accessors like hashcode, toString, and equals will automatically be generated. Also, again, like when using like an array or a list, you would probably want to override hashcode and equals, because a default would actually just do a hashcode or equals comparison, and it wouldn't actually compare the arc. It would just do a comparison based upon memory address. It wouldn't do a comparison for value. So that's probably more what you're expecting when you're comparing between arrays. You want to see if the underlying values are equal, not if it's like the literal same memory address. So in those cases, you may actually want to override the default behavior. And as mentioned, you can provide your own default behavior or add your own method definitions. Then there's pattern matching for instance of. So this is the first instance of pattern matching that was added to Java, and now it's been added in many other areas, which we'll get to in a few moments. But this was added in Java 16 with JEP 394. And so instance of, it's not as frequently of used of a feature by Java developers, at least most Java developers. That's kind of part of the reason why it was chosen. But basically, is instead of having to say like, okay, is this value or is this variable an instance of string? And then within the body of that if, you'd be like, okay, then casting it to a string and getting that value out. Now it's like, okay, if this, or in this case, a potential number object, if it's an instance of an integer, then you immediately set it to this pattern variable I, and then you can work with that I within that body of that if statement. A pattern variable is what's called flow scoped. And what that means is that the compiler will only acknowledge where it is a variable wherever it knows that this predicate is definitely true. So for this, it would just be within this body of the if. So actually, you could actually reuse I here as well, because as far as the compiler is concerned, those are two different variables. So for API updates, we did enhancements to the pseudo random number generators that was in JDK 14. Basically, we had a bunch of different ways of creating random numbers, but they were like these different APIs. They were sort of similar, but a bit different. Now we had much more consistent behavior and API usage across of them. So that'll make it a little bit easier, as well as update underlying implementation updates and make them more secure. So for checking out all the API updates, so right now I'm referencing the JDK 21 because that's obviously the most recent release. Pretty soon JDK 22 on the 19th will be released, so just update this to be 22. But our JDK engineers that were responsible for for our Java doc have been making a lot of updates to it. And what's really nice is you can see here like what changes have been added to Java for like a specific release. So if I just wanted to see what was added in JDK 12, well, I can see that here by, selecting these specific checkboxes. Of course, if I wanted to do for JDK 21, I could do that as well. That is a really nice thing, particularly as you're moving from release to release. You're like, okay, what was actually changed if you're going from like say 17 to 21? You want to see, okay, what has actually changed between these releases. You don't necessarily want to have to figure out what was changed, like manually go through and figure all that out. So that is really nice. They also had the same thing for deprecated. Again, something pretty important. If you're going from 17 to 21, you may want to see, okay, what was recently deprecated that we actually need to work on getting rid of when upgrading. And it's also a good way to know what you might need to do before upgrading as well. So that's some really nice stuff they have done.
Billy, that's a great slide. If you could zoom in a bit so that folks could see the link to that
Oh, okay.
page, that would be great. Yeah.
Well, yeah, here
Oh,
is the
okay.
link.
Sorry.
Yeah.
Sorry, I missed it.
Yep, no
Sorry.
problem. Yep, that's okay. And again, kind of back to early on in this presentation, if you go to this link, and actually here, let me see if I can post that. Oh, wait, yeah, let me pass that to in the private chat. If you want to post that into the comments, then because I don't think I'll be able to. Um,
I'll
oh wait,
I'll
here we
I'll
go.
do
I
that
know what
right
to do.
away. Yeah.
Yeah, here we go. Perfect. Yeah. Malo will get that posted into the comments so you can actually just directly click on that link and then be able to easily go to all the other links in my presentation. All right, there we go. Let's get not all that selected. There's some new runtime features to consider. So ZGC is the newest garbage collector, and it was initially added in JDK 15, and we'll see later has been updated since then. But it provides ultra low latency of sub millisecond pause times, and that's an understatement to how fast it is. It's actually well below 1 millisecond. It's also scalable up to a 16 terabyte heap. And so initially it was single generation. Now it's multi-generational. And I'll get to that here in a few moments. And I also have a great video on introducing you to ZGC as well. Helpful null pointer exceptions. NPEs are, of course, the bane of all developers. It's really nice then with this new change that it will actually tell you the variable that was actually null within that line. ARM Architecture 64 is supported across all the major platforms as of JDK 17. And there has been a few deprecations. Security Manager is deprecated for removal. Applet API is also deprecated for removal. For time, I won't get into that too much. Also removed as a NAS horn and the CMS garbage collector. The CMS garbage collector is just fundamentally superseded by the G1 garbage collector, so that is why it was removed. And for other changes, as of JDK 17, we're much more strongly encapsulating the JDK. So kind of when we first introduced the module system back in JDK 9, we allowed this illegal access permit to allow any sort of class to effectively go into certain modules or to any module. Then in JDK 16, we made that a no-op. And now then we made this no longer default. And now in JDK 17, this argument no longer works. So now you will actually have to manually say like give access to specific modules if needed. Okay, so new language features. Perfect. Yeah, for new language features here in JDK 21 and beyond. So pattern matching for switch was added in Java 21, and that is JEP 440. So pattern matching for switch, you can use when you're using switch or pattern matching in a switch, it must be exhaustive. So even if you're writing a switch statement, if you're using pattern matching for it, it would still need to be exhaustive. But also nice feature is you can actually explicitly handle null now. So that can be very nice that you don't have to have like checking to see if something is null. And if before going into a switch, you can actually handle that within the actual body of the switch now. Also, as I was talking about with Mala and mentioned earlier, is a lot of these features are starting to go together now. So before, or here we have an example of like an interface of shape. We have a triangle, circle, and square. And here we can see it's like, okay, when triangle, send it to T, and then we can then check the area to see, okay, if it's greater than or over 100, that's maybe a big triangle, and we do something with that. Whereas if it's anything under 100, then we do a different thing, circle, square, and then we provide a default as well, again, because it has to be exhaustive. Also, again, with the null, instead of having to provide like an if before this in case it's null, we can explicitly handle the null case within the body of the switch, which again makes it much more readable, much more concise. Uh, but back to one of the features I talked about before, sealed hierarchies, is the compiler can read that sealed hierarchy and it can see here because I am covering triangle, circle, and square. So triangle, circle, and square. I no longer need to provide a default case because the compiler knows I am covering all the possible use cases. Of course, you don't necessarily have to cover null because the compiler or the Java already knows how to handle that. It can just throw a null pointer exception. So that's why null doesn't have to be covered if you don't want it to be. So we got pattern matching added for switch, and we also now have pattern matching as well for records. Again, an example of how we are building upon each of these new features that we're adding. So here in this example, I'm doing pattern matching using the instance of, and basically what pattern matching with records does, it creates a deconstructor where these fields or these components I added to this record, I can just directly reference them all here within it without necessarily having to kind of going through and referencing each of the different accessors within the record. So something is from the link term. So if something's terminally deprecated. Yeah, I believe that does mean it's deprecated for removal. Yeah, or at least it's just pretty sure that's what they mean when they say terminally deprecated. Record patterns can also be combined with switches, as we see here, where I am just taking out from that record in this example here to reference the fields within it. I do have a mistake here. That should be M name, not middle name in it. Yeah. I'm not sure about varargs if anything has been improved offhand. And then finally, also we now have unnamed patterns and variables. So here again, kind of going back to now we have record patterns. Let's say in this example, I am referencing like I have customer, billing, address, and name. And so I'm checking to see, something is an instance of customer. And so I'm exploding this out to where really all I want to work with is the uh, really all I want to do is do something to the billing address. I don't really care about the name, address, CC number, or expiration. It can be a bit confusing because I still have to declare and reference all these arguments. Now, with unnamed patterns, I can just replace all those variables that I don't really care about with an underscore. And again, this isn't just about, hey, let's reduce typing, but which of course is accomplished, but by putting an underscore for these variables I'm not intending to use, it makes it very clear to a future developer without me telling anything to them that they can just look at this code. It's like, oh, all I care about from here is billing address. I don't care about any of these other variables. And then also, that's all you see here is billing address. You're not being distracted by all this noise from all these other variables that you're not using. So again, it's not just about reducing verbosity, but making code more well intentioned, which also then makes it less error prone as well. And yeah, so this just another example. So here I was referencing like I'm showing kind of drilling down to these other variables, or you can just completely ignore. Like if I'm just only to do something with name, and there's like billing and customer, I can just completely just replace that billing with an underscore, and I don't even have to bother kind of declaring any of the other variables with it as well. And this can also work with just variables as well. So here I have like this really simple for loop where I'm not really actually doing anything with names. I'm just checking to see if I'm going over some sort of limit. And because of that, I can just replace that n here with an underscore just to again show how I am not really caring about that variable, just to make it clear for future developers. Oops. And this also a really good example is sometimes with exceptions. Like oftentimes when you have a illegal argument exception. So here we have a string age and we're setting age to cat. And we try to set that for a person's age. Well, clearly that is wrong. And so we would want to catch an illegal argument exception. And really, generally, when that happens, we don't really care about that stack trace. That's a client error where we probably just want to propagate that issue back to the client or maybe log it saying, like, hey, age is not valid. And so here we can just again replace that exception with an underscore just to say like we don't really care about that stack trace, and then we can log a message or send a message back to the user saying like they entered something wrong. So for API updates, so we added sequence collections in JDK 21 with JEP 431. And so sequence collections, it's something that has, I feel like it's been a long time coming, but it makes it much easier to work with collections. So it was often very difficult if you wanted to add something to the start of a list. That was difficult to impossible. Or if you wanted to add something to the end, well, that was actually handled by default, often with just the add. But also getting like the first element or getting to the last element, particularly getting to the last element, what could be a bit annoying because you would have to be like get size minus one to get that last element. Now you can just simply do get last. And again, we do remove first, remove last. And then particularly for any sort of list with a defined order, or also we just defined order, we can do a reversed to it as well, which is almost well, I wouldn't say impossible to do, but it was extremely difficult to do before sequence collections. It was a very painful experience. So it's very nice that some of these things are just directly in the Java API, default API now. And then these have also been applied to maps as well, where you can get like the sequence key set or sequence values, reversing of the map, putting things at the start or the end of the map. So one thing to note is so like these interfaces were kind of added into the overall existing hierarchy of sequence collections. And you can see here, for example, like array list is one of the very popular implementations of collections that a lot of developers use, and you get these benefits of a sequence collection right out of the box. And one Sorry about that. Just got a call. However, for map, oftentimes a lot of developers, at least in my experience, like to use hash map. However, hash map isn't the order for a hash map isn't defined. So you would actually need to use something like a linked hash map to take advantage of that. So yeah, Project Gloom has been one of the most highly anticipated and popular projects, and finally we got our first delivery from Project Gloom with virtual threads, which is the central feature within Project Loom, and that was added in JDK 21 with JEP 444. And so virtual threads, as mentioned, that's the first delivery from Project Loom. But what it does is provides a lightweight model for using threads, because historically, when you created a new thread within the JVM, that had a pretty one-to-one relationship with the underlying platform thread, and those are pretty expensive features or elements. So like not only is it pretty memory heavy or could consume quite a bit of memory, but also it just consumed a lot of system resources. You can only make a few hundred to a few thousand threads before you would start to run into a lot of issues. Whereas now with virtual threads, the number of virtual threads you can create is nearly unlimited, because I think a new virtual thread only takes up about, I think, 4 kilobytes of memory from just its internal structure. So that you could in a modern world where oftentimes you have gigabytes of memory, again, you can effectively have many millions of virtual threads on the same system, and it can all be managed quite easily. I should have included in here a really nice diagram. It kind of really demonstrates, though, some of the benefits of virtual threads because oftentimes what we were seeing is that again because of the relatively limited number of virtual or threads you can have access to, oftentimes systems would start becoming resource constrained with like the number of threads they could have before they became actually CPU constrained. So for example, if you're writing a simple web application, pretty much every time you get a new request in, that is going to be to a new thread. And oftentimes those web applications, they do a little bit of processing, but a lot of times they're, calling a database, calling another web service, and each of those times are calling, something to check within file IO. And each of those calls are blocking. And so like a call to like a database saying like, hey, let's look up this like customer based upon their ID, it takes it only a few seconds or a few milliseconds to make that call and to process a return, but it might take tens, hundreds, or even a second or more for that response to get back. And during that entire time, that thread is blocked. What virtual threads allow the JDK to do is when it sees that a thread is blocked, it can park that thread and then process another virtual thread to make more efficient use of those platform threads. So it's a really nice thing. It's just about it's kind of giving you a lot of the benefits of reactive programming, but still following that standard imperative and blocking programming style that we're all used to. Finally added in JDK 22, this has been a long time coming, starting all the way back in JDK 14, is the foreign function and memory API. This is kind of like the central element of Project Panama, which is updating how we work with native libraries. Um, Now, my background as a Java developer is very much writing web applications. So I've never really had to ever work with native libraries. So for a lot of benefit of this, it's kind of lost on me because I just have never had to really ever work with JNI before, outside of maybe just a little proof of concept or demos. But definitely for those developers who do actively use native libraries, the foreign function memory API, I'm sure are people are very excited by it. And at least from what little I have used of it, it is definitely a substantial improvement upon the JNI in both productivity, safety, performance, and so many other areas. So definitely, if you're interested, be sure to check out this JEP that kind of gives you a good overview. And of course, we also have a number of videos also talking about the foreign functioning and memory API. Let me take a look. Just checking to see if there's any questions I might have missed. And yep, doesn't look like it. So yep.
Yes,
So
you
now I
could.
just want to
Yes.
get into some. Or did you have a question, Mallory? Oh, sorry. Okay, sorry. You're good.
Yeah. I'm sorry.
All right, thank you.
I just wanted to
Yeah,
mention
so
that target.
I'll get into some of the new runtime features and tools. One feature I think is so often overlooked is the CDS updates. So CDS is, I think, Cache Data Series now. They kind of changed the name of it a few times, but basically what it is that every time you start up the JVM, it goes through a process where it's loading all those classes from the file system, and that process is just repeated every time you try to start up a new JVM, and it's basically going to be the same process. CDS says like, okay, let's see what classes are being loaded, and then let's just get a pre-processed archive that we can load from instead, and that is a much faster process. And so they have made a lot of updates to this. This was initially CDS actually has like a long history, but as far as something that developers can work with, that started with I think JDK 9 or JDK 10. It was pretty difficult to work with then. But as of JDK 19, you can actually create a CDS archive with a single command here, auto create shared archive, and then you give the name of the shared archive. And this works both for creating an archive. So if this archive wasn't available, then the JVM would automatically create the archive. If it was available, then it would just load that archive. So it's really good because now you don't have to have one JVM command from when you're creating the archive and then a second one from when you're actually running it. It can be that same argument for both times. So that way your CI commands for when you're creating a new artifact can be the same as what you're actually running when you're actually out deploying on production. So, um, oh, how does okay? So there's a question. Actually, I'll get to that here really soon about how GDC compares to G1 GC. Actually, I have some people we can actually refer to, but yeah, I'll get to that in just a moment. So simple web server that was added in JDK 18 with JEP 408. I'm actually running this presentation on the simple web server, but pretty much what it is, this was something that kind of came out of feedback we got from educators. Is that oftentimes when new students are learning a language, one of the first things they need to do is often just find a way to host files on the local machine or something like that. And before that would often require going and downloading some sort of library or using some other language that would have access to something like that. Now that it's a built-in feature to Java, and you can simply run it with JWeb Server. And again, I'm actually running this presentation on JWeb Server as we speak. So to get to the question about GDC to G1 GC, with JDK 21, we updated GDC to be a multi-generational garbage collector. If you're really into garbage collectors, pretty much what that means is that whenever a new object is created, before in GDC, it would just be all treated as like in one generation. But there's a thing called the weak generational hypothesis, is where newly created objects often have a very short lifespan. And so by dividing objects up to whenever they're newly created, go into like a young generation, the the garbage collector can look in that generation more frequently to say, like, oh, okay, this object is no longer being used, and get rid of it. Now, technically, the really deep implementation details isn't quite correct, but I actually do have a video on both GDC and G1 that kind of goes into a lot of those implementation details in more deep detail. What is interesting and gets to the question from, let's see, ATN PGO is Netflix. We've been working with Netflix a lot on the development of generational GDC, and they just recently published a blog article, which I still need to read. I haven't had a chance yet, but they published it yesterday on their experiences of using generational GDC, because before this, they were actually using G1 GC as a default garbage collector. And basically, the longest story of this is they actually do recommend using generational GDC for a lot of use cases. And if you're not using it, maybe consider using parallel GC. But yeah, this is a really good um, explanation of using generational GGC in really one of the most high stakes settings, because of course Netflix, well, we all have Netflix, and so obviously they experience an enormous amount of load. So chances are, if generational GGC is working well for them, it's probably going to work well for you as well. Now, that said, despite all the well-due praise towards generational GDC, G1 GC does still remain the default garbage collector, and it's still actively developed. It's not being like, pushed off to the side. And so in JDK 22, we added region pinning for G1. And this kind of goes back to working with native libraries. So basically, when you're working with native libraries and you're putting variables within memory within certain regions, basically that would shut off like garbage collections with those regions. And now this region printing for G1 does allow some garbage collections to still occur within those regions. Again, my background isn't so much in working with native libraries, so I don't have much like practical experience for it, but definitely for those developers who are actively working with libraries, actively working with JNI, this should definitely be a big boost that you're not going to be running into as many memory errors. Also, this kind of gets back to our educational element, which I've kind of touched on a little bit earlier with the simple file server, and I'll touch on it a little bit later on, and as I did my introduction with Mala about being better for Java developers learning Java, and we now can launch multi-file source code programs. So back in JDK 11, before you would always have to do like Java C to compile your program, and then use Java, the Java launcher, to execute it. Um, and if you're working with like a really simple program like Hello World, that could be kind of frustrating for developers to have to do those steps to work with it. So with JDK 11, you could just do Java on a single source file program, and you could actually just run it just like that. It'll compile and run it. Now, with this change of introducing JDK 22, you can do that for multiple source code files. So you can have like, okay, your service program that's doing whatever business logic, but then have a couple other classes or source files that include like your data objects or whatever. So that's a very nice change. For deprecation removals and some other changes, so yeah, the only big one to really kind of mention and recently is the deprecation for the Windows 32 x86 port. But really, this only matters if you are actually like building your own JDK locally or something like that. Basically, we removed all the make files for how to do that because, well, not many people are on 32-bit Windows anymore. So getting into the beyond, so obviously this is a feature from JDK 22, but it's still a preview feature. One thing I do want to note about when I talk about preview features is a preview feature can be used in production. It's not like it's just there should be any concerns when it comes to being error prone or any other kind of concerns about like it not being tested enough. What a preview feature means is that the API isn't quite settled yet. So the API could change at some point between now and when it's actually finalized. But as far as like if you want to really use structured concurrency, feel free to use it in production. Just know that JDK 23 or 24, whenever it's finalized, there could be API changes. That said, for structured concurrency, if you're not familiar with it, um, so can memory leaks occur with with virtual threads? Yeah, but in no other way than it could with like normal threads or anything else. If for some reason with a virtual thread you're creating it and then it's never allowed to be destroyed or garbage collected, then yeah, it could cause a memory leak issue or any sort of underlying object attached to that. But that's nothing really to do with virtual threads. That's just something that would be an issue with virtual threads or without. But on the subject of virtual threads and structured concurrency, so what virtual threads allow for a much more lightweight way of creating parallelization. And now what structured concurrency says is like, okay, I have this unit of work, and it could actually be broken apart into multiple tasks that could be executed at the same time. A common example we've used is like, let's say you're some company like Expedia, and so, of course, like Expedia, they're going to be calling out to like a bunch of like different airlines or different hotels to see who have the best deals. So, like when making all those calls, obviously a lot of that can be executed in parallel. And there could be different rules. So, like when you're calling out to like all the different airlines to get up prices for if you're so like I'm in Kansas City and let's say I'm going to Atlanta here pretty soon for a Dev Nexus next month. Um, I want to get I want to see prices from the different airlines. Maybe I go to Expedia for that. They could call all the different airlines, Southwest, American, United, Delta, and so on to see the different prices they offer. But so subtraction concurrency says like, okay, you can take these calls and execute them in parallel, but you can also put logic around these. You can say like, okay, we're going to give ourselves like 2 seconds to get prices back from these or whatever it might be. Or we're going to say if like it's okay if one of these fail because we just need at least to get like three back or two back or something like that. Or you could also have it be like if any of them fail, then they all fail. Structured concurrency allows you to more easily break tasks into multiple or break a unit of work into multiple tasks and then reason about that. So that is going to be a really nice feature that, of course, is going to pair very well with virtual threads. And so, yeah, when JDK 25, which would be the next commercially supported LTS release, when that comes out, I think that's going to be a big motivation for a lot of organizations to update to that to really start taking advantage of both virtual threads and then some of the other features coming from Project Loom. Another one of those being scope values. So to go back to that example again of calling out to multiple services. So, for example, like if I'm going to be calling to see the price of going from like one destination to another, that value is going to be the same for all of those different calls. So traditionally, you would use something like thread local to store that value. But when you have virtual threads, now virtual threads are very cheap. So you could have potentially millions of virtual threads or something like that. So you wouldn't necessarily always want to be using local thread to be storing those values, because all of a sudden the memory cost of that can be start to be multiplied by quite a bit. Scope value says, like, okay, within this context, we can use this value. It's immutable, but it can be easily shared upon all the virtual threads that are in the same scope. That can just reference that value. So that way you're not propagating that value across all of those different threads, again, to help you save on memory. Structure concurrency and scope values to both in second preview. They haven't seen any API updates between their first preview and their second preview. So that does give a lot of optimism that we could see a our final version of them in JDK 23 or JDK 24. Again, unless we do hear some significant feedback from the community on issues or improvements that could be made. And finally, there's the vector API. It's in its seventh incubator, and it's going to remain incubator status pending when Valhalla starts delivering, just because the results of Valhalla are going to have fundamental impacts on the vector API. So it just doesn't make any sense to take this to develop it any farther until we know what Valhalla is going to look like. Oh, also we have the class file API. This is not something you're necessarily going to be working much with as a developer, but it's definitely going to make it a lot easier when it comes to upgrading between Java versions. Uh, it's a long presentation or a long or subtle topic to get into. I would definitely recommend checking out this presentation or this video from Nikolai where he goes into it. Don't tell Nikolai I said this, but he actually does a really great job presenting on this or talking about this feature. But don't tell him that, because he's going to get a big ego about it, and then I have to deal with that, every day. String templates. So pretty much that is going to allow you a much easier replacing of values within strings, and then also processing done to strings. Um, I'm really looking forward to this feature. I know it's somewhat controversial because a lot of the Java developers really think this should be a dollar sign instead of a backslash. Um, and it's caused unimaginable frustration on social media. I don't quite understand why people care that much. It's just a difference of one character. And the reason why we are doing a backslash and followed by a curly brace is because this is an invalid character set within a normal string, and it's an easy way for a Java or for the compiler to differentiate between a normal string and a string template. So that's the reason why that was implemented that way. And then finally, I only have a few minutes left, so I'll go through this pretty quickly. We have implicitly declared classes and instance main methods. As I talked about before, early on with Mala, this is one of the features I'm most looking forward to. I remember thinking back a few years ago, like, how would I explain the simple hello world main class to a new developer? Um, and okay, that is a good point. A backslash is difficult to type on some keyboard. I can understand. That's a fair enough critique. Yeah, unfortunately, sometimes it can just be difficult when you're dealing with millions of different users to find the best option. But yeah, I can understand that concern if that would be very difficult to use. Um, but yeah, so if I was to try to explain the whole war program, there's a lot to actually explain here. We have like access control with public, we have classes, we have static versus instance with static, return types with void, method arguments, referencing static values, print line, and all this. That's a lot to actually explain to someone who might be completely new to programming. So we can actually scale that down here. We don't necessarily need to include things like public or static. So that will make it a little bit easier. And then we can even go all the way down to void main without any arguments. And we can see here, we can also then step up in difficulty or step up in new concepts as well. So it's not like void main, and then all the way back up to public static void main within a class, you can step up these new introduction of elements, which just makes it much easier for new developers to learn. And of course, we should care about new developers learning Java because that keeps the ecosystem rich and new ideas coming in. But even if you don't care any about that, what's really nice about these features is that it's really building up Java's scripting, being able to use Java as a scripting language for simple utility programs. Between these changes, and then also like the being able to launch multi file source code programs, all kind of coming together to where if you have some sort of simple macro you need to run, you can actually write that in Java now instead of something like Bash, which I kind of completely all forgotten about. And then also, if you want to learn more about like all these features, like I was just talking about here with the implicitly declared classes and instance main methods, check out this article from about 2 or 3 years ago by Brian Getz, where he kind of lays out the overall vision for this. So, from final follow up links, we have a few minutes left, luckily. So, before the release of Java 21, because that's a commercially supported LTS release, and so had a lot of interest, we decided to do a whole playlist of a bunch of videos on preparing developers from all the changes between JDK 17 and 21. So definitely check out that playlist. Obviously, that stops at Java 21, but a lot of great information in there, all the same. Of course, the link to the JEPs I was showing earlier. Um, the release notes are also available right here already for Java 22. And again, inside Java and dev.java. But yeah, thank you for coming. And actually, I forgot to update this. I'm not really on Twitter too much anymore. Sometimes it is chagrin to some people who might be DMing me, and I'm like, oh, I'm sorry. A month later, I'm like, I'm not on as much anymore. So I need to update that to remove that. That said, I'll be happy to answer any questions. So I guess why not use double curly braces? I'm not sure. Like I said, the Java engineers, the JDK engineers are part of that. You know, I trust their opinion more than my own. So I can't really give a good answer one way or the other as to why that wasn't used. Um, let's see. I can yeah. There's a few things. Even here, the um string templates remains contentious. There was something, so Kedar Joshi, about Java must steal extensions, functions, methods from Kotlin. So I can't really say too much to what we're going to be doing next, but it does bring up something that I know Brian Getz likes to talk about. So yeah, people a lot of times talk about like, oh, string templates, that a bunch of other languages have also used a feature like that before, and like, oh, Java is just stealing that idea from Kotlin or C Sharp or C++ or Rust or Python, whatever it might be. And yeah, that's deliberate. So Brian talks about what's called like the last mover advantage, where instead of Java necessarily trying to be on the bleeding edge of implementing new programmer features, we're actually looking at what other languages and what other ecosystems, what new features they're implementing, and seeing how well that is actually both used by the community of developers within that language and ecosystem. Like, okay, a bunch of people said they wanted this feature. Was it just like a few loud voices, or is people actually using this new feature? If not, we may not implement it. If it is, then we might incorporate it. And we're also seeing maybe some sort of limitations around that feature as well, that maybe some developers might be experiencing. A good example of that could be withers. So we're going to be kind of adding that with derived record creation here, hopefully in JDK 23 as a preview feature. And so we're kind of learning from how like other languages like C Sharp implemented a similar feature, and actually maybe even improving a bit upon that.
Billy, you
Oh yeah,
might
and
want
so
to
that
share
Java
that
21
list.
playlist.
Yes.
Yeah,
So
here,
let's
let
let's
me
add
do a sample copy. I
Billy's
will put that
slides.
into the private chat, and then they can
I
post that to the comments as well.
Okay, so
But yeah,
let
I
me
think I guess I have a
see.
couple only about a minute left, so I'll kind of stop
Okay.
there. I don't know if Molly, you would have anything or handle the transition off to the next presenter.
You already answered all the questions, Billy, while you were
I
presenting your
really
session. So, Billy, we can't hear you. I guess you can't hear
or
me.
am I muted? Hold on one second.
No, we can hear you, but I think you
Uh,
cannot hear me.
yeah, I think. Unfortunately, I'm not
Yeah.
hearing it. It could be because my sound is messed up.
Okay. Uh,
Yeah,
right.
I don't know. Maybe can other people hear? If other people can hear Mala, that's what's important. But
Yes.
I don't know. I think maybe my earbuds got messed up. So, but again, thank you
Okay.
so much for this opportunity, Mala, and to the IntelliJ community. And I hope everyone found this very interesting. If you have any questions, feel free to email me again at billy.corando@oracle. And yeah, I think I'm right at an hour, so I will sign off, or you can
Thank,
kick me off and send on the next presenter.
thank you
Thank
so
you
much,
so
Billy.
much.